Okay, so hello everyone. Please find a seat and we will start the meeting very shortly. Okay, so it's 9 o'clock, so let's start. So this is the distributed mobility management working group. It's IETF 94. So this is a note well. I think everyone should be aware of that. And before the meeting, please sign up the blue sheet. And for mini takers, Alex, I think, yeah, thank you. Okay, so you can also take care of the Jabber, right, Alex? Jabber. Yeah, okay, Jabber. So is there any other volunteer for mini taker? Okay, Anthony, thank you. So we have a working group link here. I have just uploaded all the slides there. So please send to chair slides earlier next time because it's really a hurry this morning. Okay, here is the current status. We have published the 2 RFCs, which is DMM requirement and current practice and gap analysis. And we have 3 working group documents here. And we have other 23 individual drafts. And for the milestone, I think the 3 milestones, we have done that on schedule, but we have one that is a little bit late. That is the enhanced mobility anchoring work item. But this time, I guess the working team has submitted a new draft, and we hopefully spend some time to discuss on that, and hopefully we can have some outcome after this meeting. And for the next step, I think for the 3 working group documents, we should start or finish our working group last call. And for the anchoring enhancement, we should select a working group document as soon as possible. And for the deployment model, I think there is a working team there, but we haven't have a milestone yet. So depending on the energy level of this topic, we can discuss with AD and decide whether we should create a milestone for that. Okay, for that's the basic status of this working group. And for today's agenda, we have a morning session, and we have a lot of presentations. So it's a reminder that every presenter should stick to their allocate time slots. Otherwise, we cannot finish this morning's agenda. So regarding the agenda, we have 3 parts. The first part is the DMM track. So that's all the topics belongs to the DMM scope. The other part is the mobile IP maintenance track. We have several drafts that covers to the mobile IP maintenance. And if we have any time left, we have 2 overflow presentations. We can go that present that very quickly. Okay, so is there any suggestions for this agenda? Okay, so if there is none, let's start. The first presentation is DHCP v6 for Aero. I think it's right? Okay. can use this.
Okay, I wanted to talk about Fred Temple from Boeing, by the way. I wanted to talk about implications for DHCP6 prefix delegation under Arrow. So the Arrow client, when it comes up, it discovers the IP addresses of nearby servers and sends encapsulated DHCP6 prefix delegation requests to the server, and the server delegates the client a prefix. And when the client gets the prefix, it can now provision the prefix according to its needs. So this is the client model. Sorry, there we go. So on the one side, we have servers and relays and the enterprise network that the client attaches to. And the other side, we have downstream attached networks that the client can then join to the rest of the enterprise. That would be the LAN side, and this would be the WAN side. The Arrow interface is configured over the WAN interfaces. It's a virtual tunnel interface. And also the node has a loopback interface. So that's the client model. So there's a couple of different ways to look at the client. One is if you look at the client as a pure host, it has IP forwarding turned off in the strong end system model. It configures IPv6 addresses from the delegated prefix and assigns them to the Arrow interface. And it can configure as many as it likes. Even if you wanted to have, like, for example, one address per application, you can configure millions of addresses from the delegated prefix. And the client would then assign the prefix itself to a loopback interface to black hole the unused portions of the prefix. So the implication of this is that duplicate address detection is not necessary on the Arrow interface. Since the prefix is entirely owned by the client, there's no other possibility for other nodes to configure the same prefix. So this provides a very powerful way of multi-addressing on a client that receives a prefix delegation. Client as a router, the client has IP forwarding turned on as a router would. It assigns prefixes to downstream attached networks. The /64s can be assigned directly to downstream links, but that is not necessary on the Arrow interface still, since the prefix is entirely owned by the client. But that would be necessary on any downstream attached links that assign a /64 prefix. And what about the client as a hybrid router host? Again, it would have IP forwarding turned on. It would act as a host in a weekend system model. The client configures IPv6 addresses from the delegated prefix, assigns them to the Arrow interface. Again, it can configure as many as it likes. And the client would assign the rest of the prefix on a downstream attached link. So that would not be necessary on the Arrow interface since the prefix is entirely owned by the client. But that would be necessary on the downstream attached link. Plus, the client would have to defend the addresses assigned to the Arrow interface. And this is per RFC 7278, which is the prefix sharing RFC. So, summary, Arrow supports a natural multi-addressing capability. Addresses are abundant, so we might as well use as many as we need. DAD is not necessary since the network guarantees that the delegated prefix will not be given to any other node. Otherwise, there'd be bigger problems than just address duplication. And there is a tension between DHCP6 prefix delegation and Slack-based pseudo-prefix delegation, especially in the area of DAD when DAD is required and when it's not required. So that's, I think, pretty much it on the Arrow talk.
Okay, so thank you, Fred.
Sure.
Is there any question, comments, Bryce? Okay, so there's no questions. Okay, let's move to the next agenda. The next one is the use case and API extensions for source IP address selection. I guess Seal is here, right? Okay. Okay.
Thank you.
So you are supposed to stand in the pink circle. Yeah, yeah, it can work. You want the first page? Okay.
Yeah, this is John, and this is about use cases and the API extension for source IP address selection. Now, in this version, that the new author is added.
Okay, I help you.
Okay, yeah. Actually, let me talk about the status of this draft. And actually, that when on-demand mobility API draft was proposed by the work team, and we just appeal some missing part, and we discussed in the mailing list what is problem and what is issue in the proposed on-demand mobility API draft. And it was presented in the Dallas meeting, and it was updated and in the Praha meeting and this meeting. And for the detail, what have been updated for this draft, I will just talk about in the next slide. Okay, let's talk about overview. We just specify and analyze the several use cases using on-demand mobility API. So on-demand mobility draft proposed the 3 types of IP source address type. One is the fixed, second is sustained, and the third is nomadic. But actually that our proposal is a socket API between application to the IP stack to make more better routing or better choice of the source IP address selection. That part is something missing in the on-demand mobility API draft. Let's talk about in more detail. Actually, terminal is likely to have multiple sustained IP addresses. Actually, that is quite related with something like DMN, the benefit. Of course, that the mobile terminal may have multiple fixed IP address, but I'm afraid so. And in which cases, mobile terminal would have the multiple fixed IP address. But anyway, it doesn't matter. Actually, from our analysis and use cases, we found the very important point in when the terminal is trying to have multiple sustained IP addresses. So, but on-demand mobility draft is assuming a fixed ways of selecting the sustained IP address for initiated application, and we also think that all the selection of the source IP address should be stored in the context of the default source IP address selection rule that are defined in RFC 3484. Okay, the prior RFC, they are describing that many rules, how destination address should be selected. Also, it's describing how source IP address should be selected with the very specific rule 1, 2, 3, 4, 5. And if we look at see that how, for example, when there are 2 candidate source IP address, and for example, one is deprecated and the other is not, how the source IP address should be selected, or when they are given between home of address and the temporary address, and which source IP address should be selected. If you look at the rule number 8, they are use longest matching prefix. So, for example, when it comes to selection of the source IP address selection, they will check the destination address, and if there are multiple candidate source IP address, they will try to select more matched the source IP address. That's rule number 8 that are specified in the default source IP address selection rule in the RFC 3484. Okay, let's apply those rules in the on-demand mobility scenario on this figure. For example, ML is a mobility router. But it can be just, you can think of this generally. But this is distributed mobility router, and 1, 2, 3. And it has a different sustained IP prefix ranges. So we can call this A, B, C. So for example, MN currently now is attached to the ML1, and application 1 is initiated, and it will get, the sustained A prefix, okay? And then it just moves to the ML2 network, and then application 2 is now trying to be initiated. In these cases, okay, maybe that on-demand mobility draft is, that implicitly assuming that terminal and application 2 should get the sustained address B. But for example, when this terminal is attached to the ML3 network, and the new application 3 is going to be initiated. In these cases, maybe if we follow just the on-demand mobility implicit way, that application 3 will get the sustained the C prefix. But for example, if the destination address is more matched with the existing source IP address, what if? In that cases, terminal would not try to get the new sustained IP address, would never configure this address to the IP stack. So, in order to deliver the application's preferences in terms of could be more optimal routing or more better suited the prefix, more corresponding to my current serving access network, we have been proposing this, API. This x-axis is that showing the level of this option, whether it should be a requirement level or the preference level. But actually, about this level, I want to talk and I want to discuss with you and which level would be preferred. But anyway, this API, the proposing and the application want to get a prefix assigned from the current serving network, or I want to get a new address from the current serving network. So we would like to ask this draft is enough to get adoption for a working group draft. Thank you for your attention.
Okay. So is there any questions for this presentation? Actually, I have one for Seal. So
yeah.
So you want to define this new source IP address selection flag here.
Yeah.
But how can you know that what is the IP address allocated by the current serving network?
When this application, for example, when this application is made, application developer need to declare this option inside, and whenever this application is initiated, automatically these preferences will be delivered to the IP stack. Okay, but for example, if it is not defined, it will follow just the normal default address selection rules.
Yeah, but I mean, how does the mobile know? How does the mobile know that what is the current serving network and what is the roaming network?
Okay. Actually, that is is a missing part here, but I don't think that we have to put it this part, because that exposing mobility state working group, maybe that the other draft also rely on those mechanisms. Terminal need to get some information, so the following the next draft or something like that prefix codes and the prefix coloring draft also may address those kind of part. So this draft is just that about the between application to the IP stack, just for the delivering the application's preferences. Yes, Sri.
Yeah, see, so I think in general, I agree with the concept, but I think we need to think a bit more, make it more generic, right? Essentially, the ability for an application to specify certain properties, saying that this is my application and this has property requirements of A, B, and C. Now, that in conjunction with, if we anytime we provide a prefix, if you include set of properties, then we can do mix and match, and essentially, we can extend 3484 in such a way that an application can pick an address that best matches its requirements. So this is one example, but I think you have to broaden it, in my opinion. I think overall, then I think we should maybe take it forward.
Yeah. Okay. So yeah, I tend to agree on your idea, but if we can make some more, use cases, and if we can more generalize, it will be good. But definitely that the given example is very definitive cases we have to address, right?
Agree, but should we, we can come out with a general framework and say that this is one example, or we just focus on one example. I don't know. Maybe I would prefer, the formal, because we solve it generically. Then this becomes, you can give it as an example, and in the same draft, you can cover this case also, right? Why just restrict it to just one corner case? Because it may be, this property is one example. I can come out with 2 other properties or 5 other properties.
I mean, if it makes sense that I mean, why we have to care? It is one or many, or I mean, right?
Sure, I understand. I think, but if you have
Yes.
proper framework, then everything can be drop in, right?
Okay.
You don't have to do it for reinvent everything for every property.
Okay, thank you.
Okay. Danny?
Hi, this is Danny.
Yeah.
I'm sorry, I didn't read the latest version. So
Legacy version?
the latest version of this.
Yeah.
So I'm not sure about the differences, but we had discussions about this draft in the past, and my understanding is that in general your concern is that after a mobile node made some handoff, it might own addresses which might not be the most optimal ones, and therefore it makes sense to request a new sustained address, right? And then the application can enjoy the most optimal sustained address after handoff.
Exactly, yeah.
Okay, so my question is,
Yeah.
Let's assume we have this this flag or this option
Okay.
enabling an application to either decide to request a new sustained IP address or not to request, right? This is what this flag.
Sustained address plus this flag.
Excuse me? What?
Sustained address API flag plus this preference flag. The application should deliver the both flag.
So my question is, can you give an example of a use case where an application would prefer not to request a new sustained?
Okay.
Because my understanding is that an application will always prefer to get a new sustained IP address.
Okay, thank you for your question.
Okay.
Actually, I know that you have been asking very repeatedly. But I would say 2 things. One is that, let me ask you that. So, can you make sure no application would not require this kind of situation? You cannot never say. Second, I believe that, we need to have, if we can have more very definitive application use cases, why not? But I believe that we are making and try to make, more architecture perspective and aspect. That should be our work. If we too much focus on this slide, I don't know where we have to go, and something could be something compromised. So I think that if the given example is could make sense, why care? That you can just leave it to the application developers. Actually, we cannot determine all the things that have never happened here.
So I agree, and I cannot give you an example, the opposite example.
Okay.
And we talked about that.
Okay.
But I'm still concerned about creating more and more, how will I say, alternatives for applications to use different things. Because if an application writer has to learn so much in order to use socket interface, it could be confusing and it could lead to bad implementations. So we don't want to flood the socket interface with lots of parameters unless we are certain that we really need them. This is my opinion.
Okay, okay. Thank you for consent. But actually, that I think that once the free on-demand mobility concept was proposed, the rest of things was, that inevitable. I mean, because that the three types of the source IP address concept, has changed some, former ways of we have used for internet and for application. So correspondingly, I think that some after work I think should be followed. So I just propose this. Yes.
Right. Yeah.
Brian Haberman. So you talked about using Rule 8 in the address selection process.
Yes. As an example. Yes.
Right. Is it possible that what may actually be a better way of doing this is to employ Rule 6 in 6724 that says use the labels and actually assign priorities to the different kinds of prefixes? Because that's usually where the policy gets instantiated within the address selection mechanism is you label it with a certain preference. So I don't see an easy way to use the address selection policy distribution that's been defined, which is DHCP here. But if you were to use labels to make this address selection, then you could come up with a mobility related way of changing those policy tables on the mobile nodes rather than trying to play games with the prefix length rules.
Okay, for this, I need to check this also. Okay, thank you. And actually, at this moment that I cannot say anything because that I also need to check this in the draft. But rule number 6, right?
Rule number 6 takes into account the labels that are in the policy table.
Okay.
And if you give addresses with different types, different labels, then you can give a natural ordering to which ones you prefer.
But you are saying that using the rule number 6 that without this API we can take no.
No, not without the API, but it may simplify what Danny was concerned about, is that if the API is only passing the label of what you're interested in, then you're not making a whole bunch of complex decisions at the application. You're just saying, hey, I want label X.
Okay.
Right.
Thank you.
Right, Brian. So we can also tie that to the coloring, right? Let's say, if you deliver certain properties or attributes as part of the address assignment procedures, either in route advertisement for Slack or in DHCP v6, then the label can essentially match a particular, the color that we deliver. Yeah.
Okay.
Yeah, there was something else, but
thank you.
Okay. So if there is no other comments, I think so. You are asking for adoption for this time, or you want to try next time?
Yeah, I'm asking adoption
for this time. Okay. So let's have a poll. How many people have read this document? Okay. 1, 2, 3, 4, 5. We found. So we don't have much people have read this document. So my personal suggestion is that maybe you can trigger some discussion in the mailing list. And today you have got enough feedback and people have other very valuable suggestions. So maybe you can, if there is more people read this document and more energy level can have interest to work on this, you can try next time maybe to for the adoption call.
In the mailing list or?
We can do that in the mailing list or in the next meeting.
Thank you.
Yeah. Okay. Okay, so let's move on to the next agenda. We still have 5 minutes ahead of agenda. So the next one is the enhanced mobility anchoring. So Anthony. So as I just mentioned, this this working team has a little bit behind the schedule. So, but I think Anthony has prepared a new draft and has worked with the other working teams. So hopefully we can have enough discussion this time and to move forward this work item. So
names of the teams are missing.
you want? Yeah, you want this.
The names of the team are missing for some reason. I probably keep the wrong version of the second article. The team members still track raising hand. Don't complete and myself. So there are 5 people working on it, and they've been working on it for several months, back and forth, to come up with the solution. There was a test last time by the chair to concentrate on one solution rather than to do different solutions. And we did that. No, this is, I think sent you the wrong file. I better use
Okay.
the computer. There was a file from last year. Sorry. I'll upload that again, sorry. Oh, no. Yes. No, it's the wrong file.
Maybe we can check the case.
Can I switch to a different presentation? I come back later. I have to look for the file to remind you.
Okay, so let's go for the next agenda and. So the next one I think is Danny. You want to present first? Yeah, this is all of it.
Working number 1, which is the limited exposure and selection. After is the working team leader, and I was asked before, he's not here, and he wasn't here in the previous response. Hello? Okay, sorry. Oh, so I was saying that Alper is the working team leader, and I was asked before if he's still the leader because he's not here. So he is still the leader, and you're all welcome to send email to him or on the list, and he will reply. And actually, he was kind of frustrated that there was not too much work going on in this team. So he is welcoming new inputs and new work. Okay. In general, the working team had 4 items or 4 subjects that we were working on. The first one is describing how an application can request certain stuff regarding the source IP addresses or the services that it needs. We have the on-demand mobility draft, which was adopted by the working group, and it has been there for quite a while. No new inputs, and we were asking to initiate a work group last fall for this document. I presented some work on link state information exposure last IETF. I don't have a draft yet, but I will hopefully have a draft for the next IETF. So I'll put it on the list and we can discuss it during the next face-to-face. And we're looking for additional stuff. So anything you have, please update us and so that we can work on new stuff. Okay. Items number 2 and number 3 were related to, okay, the application requests from the stack certain stuff. How is that request forwarded to the network? So there are 2 drafts on these items. The DHCP on demand draft, which I presented, I think about the first version was about a year ago, and I received some inputs from various people, added them to the draft. Revision 01 is the new revision which was ready already for the previous face-to-face, and I didn't receive additional inputs on that. So I'm assuming that it's okay to be adopted by the working group. So I would like to ask the working group to adopt this draft. Another draft that was written by Uni exists for quite a while, and we need to figure out what we want to do with that. Uni didn't ask it to be adopted as a working group draft, but we should ask him what he wants to do with that draft. Okay. So I just want to point out that when an application requests an IP or an IP address type or service, one of the ways to convey that to the network is through DHCP. But there are other protocols in which IP addresses are assigned or manipulated. And we probably need also to look at these alternatives and figure out if we need some support for these protocols as well. And we're seeking for help from the working group to look at these protocols and suggest some new work.
So one comment.
Yeah.
So on the previous slide, so Yoni's draft is covering the NDP. Actually, your last topic, right? Address type needs, right? On address the research other means for conveying IP address type needs, right? So MIP-v6, IQ to NDP, right? So that NDP is the draft Corona is covering the NDP case, okay, right?
Okay.
And IQ we thought about it, but we never got a chance to publish that. But we plan to do something there.
Okay, are you a co-author of that?
Yes.
Oh,
Yeah,
so
yeah. So we did like, one we published in DHC and another we published for the, in other words, one for DHCP, another for neighbor discovery, right? So both are covered, and I think,
so,
we
so
need-
for neighbor advertisement, do you want the working group to adopt that? I mean, you didn't.
yeah,
request
we
that,
need to
right?
make a call. Yeah, I
Okay,
think
okay.
we'll make that request. Yeah.
Okay. Last item was something that, in general, the item talks about, okay, an application can elect to request IP mobility services or not. If it doesn't request IP mobility services, it probably has different means of maintaining an IP session. And it was about discussing how this happens. There is one draft, but nothing really is happening in this field. So either, I mean, we were calling for additional work. Either we get more work, or maybe we should drop this item since maybe it's not interesting to the working group. So, if we don't get additional work, we'll probably drop this item.
Okay.
Okay, and that concludes my report.
Okay. So,
Two action items.
okay. So basically, for the first item, you are saying to, okay. So you are saying to write a new draft for link stage. So is this new draft will belong to the first item?
Excuse me?
Do you plan the new draft that you are
Yes.
you are planning is
Yes.
belong
Yes.
to the
Yeah.
item 1? Okay. And for the item 2 and 3, so you are request the working group to call for adoption for this one this time?
I'm asking for to initiate a working group last call for the on-demand draft
Okay.
and for adoption of the DHCP draft.
Okay. So let's go back to the on-demand draft. I think we can initiate the working group last call for this one after this meeting on the mailing list. But before that, I want to make a poll. How many people have reviewed this document? The latest version of this document. Please raise your hand if you. Okay, none. So I really suggest, people have to review this document. I think this has been adopted by the working group for a while, and the working team has make a lot of contributions on this, put a lot of energy on this. So to make a successful working group last call, we need sufficient reviewer for this document. So Danny, I also suggest you try to talk to people offline to get more reviewers.
Okay, I just want to point out that actually this draft has nothing new compared to the last individual draft that was posted.
Okay. So, yeah.
Marco, just one comment. Maybe I don't recall this in the right way, but you are requesting more input or drafts on item 4. And if I remember right, wasn't there a draft from Alpha doing exactly this?
There's one. Yes, there's one draft.
So what's missing? Interest or details?
Both.
Okay.
No, I'm sorry. Regarding Alpha's draft, interest. Nobody.
Okay, so reviews.
We didn't get any feedback,
further.
but we didn't expect each topic to have one draft. We expected to have several drafts. I mean, there are several things that could be done. And it seems like nobody is really interested in that area. So, nobody's interested. Maybe we should drop.
Okay, clear.
Okay, and for the
DHCP.
DHCP one, so the same question. So how many people in the room have read this draft, the DHCP one? This one. please raise your hand. Okay.
Well,
Mm,
I received
no-
inputs from people, so I don't understand
Okay.
that. From several people.
Brian Haberman, and speaking with my 80 hats squarely on my head, possibly you've gotten comments from people who have read your draft who just aren't here,
No,
which,
no, no.
which is fine, right?
No, there are.
My question for the room, and my first comment was just for that, is has anybody read any other drafts other than their own? Oh, okay. Just checking.
Okay.
I'm sure if jet lag had still kicked in on it.
I don't know if I need to, I didn't think of preparing a presentation or a reminder of the DHCP. I could do that for the next face-to-face if it's necessary. But I did receive inputs from people in the room that are here right now. So I think there's a misunderstanding.
No, I think part of the problem is not just with this work team, right? In every items probably except for maybe the CPDP interface one, FPC one. Except for that, I think in general, others we are talking and we are pausing and we are giving so much of gap. People are forgetting. You know, I think that's probably.
So
I think, yeah.
okay. So what I'll do is I'll prepare a presentation for next face-to-face and then ask for adoption. Okay?
Yeah.
Okay, thank
Sounds
you.
good. Okay. Thank you, Danny. So Anthony, are you ready? Yeah.
Just email the current copy so it can be uploaded. Okay, so these are the co-authors. Okay. Okay. Oh. I just can send in this box. And these are the summary of the changes. So we basically concentrate on the mid section switching, and then we switch. We either use the new IP address or use the old IP address and then switch it to the new anchor. So this is the picture to show it. This is an anchor, this is another anchor, so you have the different network. The mobile move from one to another, and it's talking to a corresponding node, which was talking to the old mobile. And this edge router is entering the IP1. This is main network. The edge router is entering the new IP address. And if you need to use the old IP address, then we will have to use the CPP segregation, BGP or SDN or all these combinations, so that this address will now belong to this the new network, so that the BT update and all take place, so that the packet will go directly over there. And this is the case when you need the so this is the case for this section switching the anchor. And the other case is that you don't need it, and you don't need the you don't need to use the new. When you don't need to use the old IP address, for example, application can take care of it, then you just use the new IP address, or if the section has already determined it, and when you open a new section, you can just use the new IP address. This way of changing the anchor had been talked before by many people before, so we could also keep that. So these are the two options to switch to the new anchor, and that's why it's described in this chart. So and the next one is on the flow chart. This one is that is basically we use the new IP address as change anchor. So the flow chart will prefix H router, new X router, and the HTTP could be co-located or some separate one. It doesn't care. So it just say HTTP servers and the corresponding node over there. Initially, the mobile node attached to the previous H router, and then you configure IP and so on, and then you start a flow, with the CN using IP1 and IPCN and other parameters at the 5 flow, and then you attach a new network route solicitation, and then you RA and with the prefix true to it. So it takes the new address and then use the new address, and then the new section, the new flow will be here. Now then the next slide will basically insert steps in between here and there so that you can use the previous address. All the rest are the same except this part. So when you do a route solicitation, this one has to learn that you have been using the OIP address. So and this the previous X router does the release the prefix, and then the new X router do the prefix segregation, request and reply, so it gets you there, and then you do the BGP update, and so that now the IP address is moved over there. Therefore, the new flow will continue. Now you also need to allocate. So basically, when you move to new network, you need to, the mobile is going to have two different prefixes, P1 and P2 in this case. So when this flow has terminated, and then you start a new, it would, when no other sections are using prefix 1, then it will be gone. Then you will be left with prefix 2 only, and then the new flow will use the prefix 2. And let me finish it to make sure I have the time to finish, and then we'll come back to the question. And then the last slide is on the relation to the other working groups. Because the node has to know whether it needs to do section continuity or not, the network needs to know about it. So it deals with the other job from the exposing the mobility state with it, and there are different proposals. And the job is referring to them when you are using those. And then for the signaling, working group, macro or most any some of the commands written here is for the control plane can be centralized. So it's centralized. Those commands would be implemented in a way using messages between the control plane and data plane, and we will have to compare which command does what the take the solution. And then for the deployment scenario, we draw the relevance. We use the same model. I forgot to mention one thing is that this one is using a distributed data plane with the working management data plane, and then the control plane can be centralized or distributed. This picture showing the centralized control plane with the working management control plane and the location management also in the control plane, and this location management is taking the information that whenever you see IP1, it is associated with the IP of the H router 2. Okay, yes.
Can you ask a question here? Can you go back to the call flow? It's just one clarifying question. Yeah. So here, where you probably one more where you do the DHCP, maybe one more click. Yeah. So in this case, as I understand, you're moving the prefix from PAR to NAR, or right previous to the new access router, right?
Yes.
So yeah. So there you said you're doing a BGP route update. Are you doing BGP route update for /64 prefix? You're doing a prefix delegation, right?
This should be released, request reply, and after that, because this prefix belongs to that already, so this router would have this router would be sending BGP update.
That's what.
To the neighbors. Yeah.
No, hold on. You're doing your allocation is for /64 prefix, right? You're doing DHCP prefix delegation.
Yeah.
You're doing a /64 prefix, or because this is a mobile, you're doing a allocation search or a something that you host it on a prefix.
Oh,
so
okay. This
you're
is
not
64, so it's 64.
okay.
Yeah.
So now, if there are two mobile nodes,
Two
mobile nodes attached to the same previous PAR, okay,
Yeah.
in MN1, MN2, you are taking two different prefixes, prefix P1 and P2, two /64s, okay, but from the same block.
Wait a minute,
Two different mobile nodes, MN1 and MN2.
Mobile.
Yeah, MN1 and MN2.
They would be using different prefix, right?
Sure, but
Okay.
they're getting it from the common block /48 or something. Right?
Oh, okay.
Yeah.
Yeah.
Now, MN1 stays there, MN2 moves.
Yes.
You're doing, my question is, are you doing BGP route update for /64 or
64.
it's like you're moving host routes?
Well, if this is a host, then you move a 64. If this is a router, okay, suppose you're using network, network will be a different issue. And whatever that prefix owns, it is moved. It is basically moving this prefix.
So these are host routes, literally in one sense, yeah.
It could, if this is a router, you can move the whole thing. It depends whether MN is a host or a mobile router.
Why does that matter? What are the address that you're giving?
This draft is talking about host.
No, hold on, let me say that. What are the prefix that you're giving? You're hosting it on the MNAR link. It is not a delegated prefix. It is a hosted prefix. The router is still hosting that prefix. Agree? So it doesn't matter whether it's a mobile router or a mobile node. It's on the egress link of the mobile node.
Okay, let's take it as a host first.
Okay, it doesn't matter, host or router, because the prefix is hosted within the mobile node's egress link and access router. Agree?
But it's owned by the mobile node, right?
But it's hosted by the router. You're not it's not a delegated prefix, it's a hosted prefix.
Right, so this one has to release that prefix, right?
Okay.
Maybe I'm not.
Well, this is Carlos Bernardo, UCCM. I kind of share the comment from Sri on that you are making host route updates with BGP, and that I think may raise scalability concerns. There were already some discussion on that with Pete's draft that I think was similar, right, on BGP.
Yes. Yeah.
So that's my question will be whether you have analyzed or discussed these potential scalability issues in the draft, because I don't see how a kind of host route solution mobility based on host route updates will actually work in a.
We are looking at it either as a distributed routing or centralized routing. Okay, when it is in centralized routing, the SDN will take care of it. Okay, and we put it generally enough that it can be both distributed and centralized. And when it is distributed, all this routing will take time to converge. Okay, so it could be slower. It may not meet all the requirements, but the trend would be towards a centralized control plane. And in that case, all this BGP and all this command will not be this. It may not even be this command. It would be just a control plane talking to the different switches. Okay, but in the draft we make it like that. But in the realization, it would basically, I mean, in BGP deployment, if you ask my opinion, it would be basically everybody would be using centralized control plane and will be this command. But we are drawing the equivalent because we don't know what those commands are, and we know that in the old world will be the distributed routing protocol will be using these commands. Okay, and whatever. But once you have this command, then to realize it in the central plane control plane, it will be the equivalent of those commands. And the issues that you mentioned would probably not be overcome because of the centralized control plane. It would be faster.
I think scalability issues will be there anyway. I mean, with SDN, there are also issues on that. But in any case, until you provide details, only having the BGP on the table, I think that solution may not realistically work in a running network. That's my comment.
Detail in terms of what? BGP was just telling the neighbors, right?
Yeah, but I mean, it would take a long time, and
yes,
I think
exactly.
That's
it would take a lot of
solution.
Time. And McCann did an analysis saying that those will take time, but not that long. I would go through the whole network. He did some experiment, and there's some data to show it. But on top of that, I would just, instead of talking about that analysis, I would just saying that use the equivalent of those commands in the SDN network.
Just as a side note, we have a published paper where we analyze the different performance, and we can provide you numbers about the performance of a routing-based solution. It's really slow compared to the others.
Is that distributed routing or centralized routing?
BGP base. We have also
distributed. Okay.
yeah, but we have also SDN results, BGP routing base and PMP6 base comparing all of them. So you can take a look of the numbers.
Okay. I'll look at that. But basically, when you use the SDN, everybody has been talking about SDN. So, and that part will be the scope of Marco and Dennis work on how this command will be actually realized.
Okay. Right.
Thank you. I'll see that.
This might already be clear to everybody, but we're not talking about the global BGP of the interdomain routing core here. We're talking about a private BGP instance that happens within the mobility management scheme. So it's not dumping host routes into the public global, BGP tables, in case that wasn't clear. And the other thing too is that BGP is used for macro mobility events. It's not used for micro mobility events. So it's not as susceptible to churn that would happen if you're doing every time the mobile node moved, inject a new prefix or withdraw a prefix.
Thanks for clarification.
That was actually a very good clarification, Jörg, because I wasn't aware of that. I just have been poking Jörg. I have been poking in here only very rarely. But so I had the same comment that was made before. And I was wondering whether you can actually ensure that the mechanisms that you are designing is going to be only utilized within a certain network. We heard this gorgeous talk in, I think, 2006 about how connection by Boeing works with BGP mobility for networks on airplanes. And they had a long list of all the issues that would come up when you apply this to network, when you apply BGP to network mobility at an internet scale.
Right.
And so how do you, an important element would be, how do you prevent somebody from using a tool that you have designed for a certain purpose, for using it because it's convenient and it's available for a different purpose? And that would be something that I guess would need to be addressed.
Yeah, so there's a scope in which this is applicable. Okay, if you're talking about moving over the whole global internet, it would be impossible. Okay, it's something, for example, if you're inside the same data center, and I'm only doing the controller to talking to all the switches in the same data center, okay, that could be possible. And in addition, if you're just moving from one base station and another mobile station, you only need to do the tunneling as Fred had mentioned, so you don't even have to move like that. So it's only when you're moving from one network to a different network and probably inside the same data center, okay? And if you're moving from one subnet to another subnet, you don't need to do that.
Okay, just moving from one network to another, from one base station to the next may incur significant changes in terms of movement, in terms of network topology.
Yeah, moving from one base station to another base station would be whatever you're using in the 3GPP that's already, you just move the tunnel on one to another, right? You do that. So a lot of cases you don't need to use. Yes. Marco, yeah. Oh.
But you said within a local domain, maybe I didn't understand your comment. You didn't, as far as I know, you didn't say that this is, this can be used, this tool can be used only when you are migrating a prefix from, let's say from East Coast to West Coast, right? You didn't say that. What is the scope? Can it be done within a small, within a site or intra-site? Are there any considerations? Have you thought about it?
So basically, about the edge router, you have to stop somewhere in Peter McCann's draft. The update goes up to the aggregation or some point in which you don't have to change anymore. You're not talking about propagating BGP to the whole world, but propagate up one level so that all the packets are going there anyway. It will either go to this or that one. Now you propagate only to the level in which there's a common aggregation point. If that aggregation point exists, if there's no such aggregation point, everybody is going to internet. They will not be talking about that.
But how do you restrict that? As far as I know, a mobile can move from AR1 to AR100. AR100 can be completely in a different routing domain. How would you?
That would that would require some other solution, not this one. This one is basically, I'm in the same data center. I have a controller. I'm in charge of it. If you're moving to somewhere else, you would have to use the tunneling or some other mechanism, which is not covered in here. We tried to talk about in the previous draft, but there were too many solutions. So we could have continued to talk about if you're doing a global move, how are you going to move it with tunneling? There will probably be a tunneling, but that would require different draft.
So okay, Anthony, I think I also agree with previous comments that you need clearly scope of the BGP routing part, and yeah, we don't have enough time for this topic. So Peter, you want to last comment?
Well, one comment from my side. So there are different aspects to that, and I remember well the discussion about Pete's draft, and yes, I can confirm that he actually said that it scales because it applies to a certain range in the network.
Yes.
And also we have to take into account that that state may be a transient state just to serve IP address continuity and may be deprecated after the sessions using that deprecated address terminate. That's one thing. How long that takes to propagate that state, that's a different story. So there are different opinions about using BGP here. So for that use case, we have to take care about two things. One is migrating the context from the previous to the new access router, right? So the binding.
Yes.
And the second thing is how to adapt the route to make packets being routed from topologically correct to an incorrect address. And you propose the use of BGP here. So is the use of BGP part of that solution, or is it just an example?
It's an example of a solution, BGP.
It's a solution.
BGP is an example because we don't have the new command in the control plane, the data pack. You have to wait for your signal.
Yes, but as said, that there are different
And with the
solutions to
existing
solve that
command,
problem.
it will only work in limited cases. So it's basically doing it on what we have already have.
So using BGP as an example is fine,
Yes,
but
an example.
binding it to the solution, I would disagree.
Yeah, it is an example. You're right. We have to wait for the new command in the control plane to realize.
Okay, so Anthony, I think a good thing is that many people are interested in this topic. So I suggest you can organize a working team meeting to use opportunity to make this draft more mature. And another suggestion is I think this working team should align with other team, like what Peter just mentioned. You can consider the CPDP signaling or other mechanism that's already accepted by this working group in the mobility anchoring working team.
We have already reference to a number of the draft mechanism. Once they are adapted.
Okay. Okay.
Thank you.
So let's move on to the next agenda. That is a communication prefix cost.
And that's not Peter, actually, that's Marco.
Oh, sorry, it's Marco. Yeah.
Okay, so this is the draft on prefix cost, and it's been updated to a version 2 based on a number of comments we got the last time.
Yeah.
So just a brief overview of the comments that we got the last time and what we did to update it. So one of the questions was the motivation for the draft itself. And we've added a whole section on the motivation, and I'll go through it as we go. But primarily this is due to lower latency links. I mean, what happens is as you move, the cost changes, and we want to address that. I'll get into the details as we go. And also what costs are being optimized. So that's being addressed in sections 1 and 3. I think we've added some text there. Another question was whether it required additional signaling, and I think we can clarify that there's no additional signaling. It's part of the RA options part of. So the next question was about whether it impacts layer 2 events, and we're not addressing layer 2 events in this case. I think that's specifically the issue that we want to take care of. As a MN moves from one link to another, the layer 2 link itself may change, and what we do not want is to have the MN go and do a DHCP or something like that to figure out if the costs have changed. And instead, only when the route itself, I mean, when there's a new router, then it gets informed. So that's one of the, so it does not correspond to link layer event. And the question, and the fourth question was about whether it's addressing end-to-end aspects of the flow. And this is not addressing the end-to-end aspects of the flow. This is specifically related to the additional costs as a result of the change in access router. We assume that the end-to-end costs can be done by protocols such as MPTCP and so on, which you know, there are good methods for that. And the last question was about host or application behavior when the prefix cost changes. And I think here we need some more work. We've included some definitions, I mean, in there as to how the application gets informed either via BESI polling or you know, alternative methods, but that we need further work on. So that's a rough state of what we have added from the last time.
Okay.
So now I'll just go through the introduction, go a little bit more in detail on the motivation, and then you know, the proposed method. So going again from here, we have not changed anything here, but when an MN moves from one IP attachment, so the key point is it moves from one attachment point to another. It really does not know about the amount of state in the network on behalf of this prefix. So it's not related to the initial attach. Then, you know, if you take 3GPP, there are concepts like an APN or a PDN connection that allow you to define what kind of a prefix you need in the beginning. But in 3GPP networks also, you do not move the router. So the change as you move routers, there are no means to express them at this point. And so that's from the network, from the MN side. It needs to know what is happening. From the network side, it does not know the state of the connection itself. For example, the MN may be in the middle of downloading something, and you don't want to have to switch IP addresses and to a more optimal connection at that point. It would be, you know, counterproductive. So from this, the point is that if the cost can be communicated of these additional resources, then the MN can make a decision about when to release and acquire new addresses. So again, you know, summarizing those points, the MN decides about allocating new addresses and releasing old ones. And the second point is that only the network has information about the cost. The MN does not know the network topology. So the proposal in this draft is to provide the cost of maintaining an IP prefix to the MN. And just added as notes because these questions came up before, this is not about end-to-end latency or jitter. And it is not about the layer 2 link either, or it's not about the initial connection itself. So this is the.
Sorry, can I ask a question? This is Danny. I understand the need or the benefit of being aware of costs, but I'm not sure if, again, this is an issue of complexity, if we would want to inflect such knowledge to application developers, meaning they will have, according to this notion, application developers who want to benefit from these things will have to.
I'll say that, you know, we do not want that complexity either. And I think there are standard ways of mitigating that.
So, and are you going to talk about that?
I'll briefly touch on it. I think that's one of the.
So just a suggestion I have is rather than maybe you could twist this a little bit, and rather than providing information to the application about costs, you could expect applications to indicate what they're about to do and let the network figure out and take that in account and figure out what resources are going to be allocated. So for example, if the application knows that it's going to be a very long FTP download, it should say X amount of gigabytes or something like that, and then the network will decide what to do. Or if the application is a real-time application and it cares about things like jitter and stuff like that, it could indicate that when it opens a socket, and that could be communicated to the network, and the network will provide the resources rather than doing the other way around.
I think this is an additional method, and I think I'd be happy to discuss this with you offline. That's great. Just to clarify on the complexity of the application itself, I agree completely that we should not make the application developer have to understand all of these complexities. I think it's standard in 3GPP devices to have a communications manager, which sort of takes in the policies and so on and hides these things from the application. That's one way. We can look at others. So I think between the two, and I can talk to you offline anytime.
But I do want to make one comment on that, John. Right. So we are saying that this is not about path characterization, right? It's not about jitter. It's not about latency. It's not about topology or anything with respect to hop count.
Yeah.
Right. So there's none of them, right? But still we are saying there's something called an abstract term, something called cost, right? And we are not saying exactly how a client is using that information. We are not telling how exactly that's being computed, right? We are not doing that part, and we are not telling exactly how it's using it. I think that's the problem of the big.
Let's just go to the next couple of pages. I have something, so that in general people can follow what segment it is, and I'll take up your question at that point, and you can convey that too. I understand the point you're making, and we can. I think that requires clarification, and we'll need to do that too. So just in the general context, what is it? This is to start the case. I think this is a general case of DMM in general. If you look at the figure on the right side, we've got rather trombone connections, with a centralized anchor and so on. And what we're saying here is that if you have the router located closer to the MN, then it's a more optimal route for especially different kinds of traffic flows than what goes to a central server and so on. And these are cases that come up in NJMN and other things. The type of traffic flows, latency, bandwidth, a whole bunch of things that related to that. And this provides an optimal case. So now looking at the figure on the right side, you can see that the MN is now attached to AR1, while MN2 is attached to AR2, and there's a communication flow for, for that case. Now going to what happens when the MN1 moves to AR2 and still maintains that same flow. You can see on the figure on the left that basically it's going to use IP1 and go from AR2 back to AR1, back to AR2, and down to MN2. And that's a rather unfortunate way of routing things. And the point is that the MN does not really know that this is happening.
But I do want to make a comment here, right? So sorry to interrupt in a way slide, but if you look at Yoni's draft on where we mark the prefix as a home address versus a roamed prefix, the distinction is a binary, right? Essentially, is it a local prefix or remote prefix? If you provide that indication, why would that problem be still relevant in this slide?
So both of these are in the home network. AR1 and AR2 is still in the home network. So it's not about home or remote in that sense, and it would still end up with the same problem.
But it again goes back to the question of the cost, how you're measuring it. Yeah.
That I agree needs elaboration, and definitely. So again, just to make a point over there, AR2 is advertising both prefixes, IP1 and IP2, and it's advertising IP1 with a high cost now because of those costs that I've listed up there, the route and forwarding and tunnel costs related to AR1, AR2, and the backhaul tunnel in between. Whereas for IP2, it's advertising a lower cost, which is related to only the forwarding resources of IP2. So now it's up to the MN to decide what to do. And moving to the figure on the right, and then one decides that, one of these flows is ready. I mean, applications is ready to move that IP address and use IP2 with a low cost, while the other one is not yet ready. You can assume that in a subsequent state, and I'm assuming that this is for a very short period of time, maybe a second or two, or however long it takes to complete that transport or whatever that is, but not in terms of, 10 or 15 minutes or something like that. So you can assume that the red flow also in due course of time moves to the more optimal route. And the idea is that at any point, the network is not providing very circuitous kind of connections, using a whole lot of additional resources in the access network. And also the MN is getting better service as a result of shorter routes and so on. So that's the point that we want to make here. And again, it's not about the cost of setting up that connection, say from MN1 to an AR, which may be addressed by, in 3GPP, you have PDN connections and APN to express those kinds of costs. And I guess, in the IETF also, there are methods by which you can express that cost, which, we should look at. This is talking about the additional costs in terms of routing that mobility.
I'm sorry, but we're running out of time. So can you keep your comments short? Yeah.
I keep it short, my colleague. So if I remember the discussion about the work item 1, which was exactly proposing to the UE or to the mobile node the availability of a fixed, a nomadic, or sustained IP address, which serves transit IP address continuity service. So is this a mechanism that complements this approach, or is it an alternative? Because this is pretty mobile node centric, right? So you communicate the costs of continuing an IP address use to the mobile, and the mobile should decide. So in the work item 1 team, I understand that the approach is to offer an IP address, and the mobile node just assumes there is continuity of the IP address.
Short answer is it's complementary. You can assume that you ask for a nomadic IP address in the beginning, and then the cost changes as it moves around. And that's what this is trying to address.
Okay. John, yeah, but we are running out of time. Yeah, you can give us a very short summary.
Very short one, because this came up in, I'll try to finish it very quickly. So the question was how the UE knows about, the MN knows about these costs. What we're assuming is that in a policy domain, the MN gets configured with policies that say what it should do if it sees a cost of some sort. And then it receives this cost via the RA and uses a policy to determine what cost the network is going to impose. In addition, the MN has policies related to the application itself. So it uses the combination of the policies related to the network, what the network provides that may be related to charging or other aspects, and it has costs related to what the application should do. Can it tolerate 5 seconds of something or not? And it uses the combination of these policies to decide when to move an IP address. I think that's pretty much it. This is what we have, and I think it was suggested in some of the conversations that we should talk with 6-man and MEF, but I think I've already started to talk about this, and we'll complete it.
Okay, thank you, John. So let's move on to the next item. That is control plan, data plan separation. So macro. Yes, it's coming.
Okay, this is briefly to update you on what we discussed since last IETF about the control data plane separation draft. So we had a couple of offline or site meetings in Prague to investigate the open items associated with this draft, technical-wise. And I'm not progressing.
Okay, let me do that. Okay.
So,
it's fine. Yeah. The second one. Okay. This one.
Okay, that's not this one. Okay, just briefly to remind, the objective of that work was to design a protocol between mobile gateway, control plane, and data plane. And this is the architecture we adopted, which is a client function and an agent function, where the client function is supposed to be co-located with a mobility control plane function. And the agent function is associated with a data plane node configuration. So the intention was to have the common semantics being deployed between the client and agent, whereas the agent can be deployed on a data plane node itself or on a network controller like an SDN controller. So the semantics was the goal to have the same, irrespective of the deployment. So this is still the current status. We did not update the draft for the following reason. It's mature in the sense that we address a couple of attributes which are needed to exchange between the control plane and the data plane. We have an information model being provided, functional architecture, traffic descriptors, and associated attributes to declare the policy rules, like encapsulation, which encapsulation type is requested, QoS type, or forwarding decisions. So the sections about protocol operation, the red part here, that kept us busy during the last months. We had a couple of telephone conferences to investigate this, because we saw that it's not so trivial to have common semantics for the different deployments. And that's mainly what this presentation is about. So also we have some information about event scheduling, which may be required to detect failures or to monitor chargeable events, but also to query from the data plane, from the control plane, to request the update of the data plane states. So here discussion is needed, but that's somehow stalled because of the discussion which I would like to tell about now. Next slide, please. So the discussion at a glance is that we can deploy the agent of that functional architecture on a centralized controller, network controller, or on the data plane node itself. So data plane nodes, of course, are much more distributed than a network controller. So the principles we discussed is how to communicate what the control plane function needs from the control plane function towards the data plane. So the current approach is rather declarative. Declarative means the control plane function, which terminates proximal IP or GTPC protocols, gets a lot of information about states required in the data plane. So dependent on where different functions are, knowledge about the data plane node, knowledge about routing on the data plane, we could have a declarative approach by just constructing a packet which has all the information about what the control plane function needs, like a tunnel endpoint. We need that certain QoS. Or to have a more imperative approach. That's what we call imperative. So if more control remains on the control plane function, we may have to have a more fine granular control protocol between the control plane function and the data plane. So that's the main debate we currently have. And that's what we want to illustrate in the next slide. So I need to remain in the cage, right? So we have the two deployment scenarios illustrated here. The left one is the mobility control functions like an LMAC, maybe separated from a network controller. And the network controller has the logic of a network, so mainly about routing and data plane node awareness. And each data plane node has its interfaces. So routing awareness can be assumed on the network controller, whereas the mobility control function is aware of the mobility state. So there is a clear separation. The other deployment where there is no intermediate controller between the mobility control function and the data plane node, we have different kinds of scenarios. So in one case, the data plane node is an autonomous box. It has all the routing information. So we discussed there are deployment scenarios desired where some of that control is elevated up to the mobility control functions. In that case, the mobility control function has much more awareness and control over the data plane nodes. That means that needs to be reflected semantic-wise on the protocol which we are trying to standardize. You have a question, John, or comment?
Yeah, it's just a comment, John. I like the idea of the abstractions, and I think I just wanted to state that that would be one of the things that I'd like to work to see. The more of the abstractions related to the figure on the left side.
Okay. So abstraction could also apply to the right model if we assume that the data plane node remains an autonomous box. If some of the data plane node control is elevated up to the mobility control function, which is one use case we discussed, more control and more semantics are required on that interface. So that's what we currently analyze and see we have maybe an overlap or the same types of attributes which we need, like tunnel information, endpoint information, QoS kind of description between these two models. But if we elevate control up to the mobility control function, we have clear differences in the messages which we need to exchange. So the control messages may differ between the two approaches. So that's what we currently investigate, and we need to somehow converge on how we reflect this in the specification. So far, the specification is more a descriptive approach, as you see on the left side, which means if there is a mobility transaction, a registration of a mobile device, the mobility control function extracts the information it needs from the data plane, which is a local tunnel endpoint, maybe some QoS, and constructs a description in one message and sends it down to the network controller. And the network controller has the awareness of routing, has control about the different data plane nodes, and then can enforce this kind of description to a protocol operation to set up the states in one or multiple data plane nodes. On the right side, you may have multiple control commands to set up a tunnel and to set up scheduling according to the requested QoS. So more control may be needed. Attributes may be the same, but control messages may differ. So far we have a certain description of protocol operation in the draft. And if we somehow want to address the right model with more control and additional attributes, we have to decide how much of the protocol operation we keep in that standard. So either we cover clear separation and two different models, how to use that attributes and commands, or we just get rid of the protocol description at all and just cover the semantic specification. But we clearly will lose details here and make it more difficult to really take this specification then to build a product or implementation. There are differences also in how much, mobility control versus data plane node control. Mobility control is clearly the task of the mobility control function. There are different views on how much data plane node awareness and control should remain in the mobility control function or be relocated to a different kind of controller like the network controller or remain in the data plane node. In the very end, it has a lot of impact on the interface which we are specifying. So if we go for a descriptive approach, a single message may be suitable to set up a state in the data plane. On the right side, we have more control on the mobility control function, but we also have to take the cost of more signaling between control function and data plane node. So there are different aspects to that. Next slide, please. So we received some feedback based on the current draft, which we didn't update yet, so the comments have not been taken into account yet. So a lot of comments from Lauren and Lyle about carrier formats, carrier ID format, data plane filters, packet replication, and how to reflect our attributes which are needed for the 3GPP kind of deployment in that draft. So we will revisit these comments and, of course, reflect them accordingly in an update of the draft. And thanks for the comments along. Next slide. And yeah, there is related work. A lot of other standards organizations are addressing the point of control data plane separation. So in 3GPP, found a study on feasibility to separate control from data plane. The ONF Mobile Wireless Group is actually looking into 3GPP gateway decomposition in control data plane and to apply SCN. So here clearly that kind of work from the IETF can be deployed on the SCN scenario on the northbound interface of an SDN controller. But that's one deployment of many. Next one, please. So the next steps is clearly to conclude the analysis and to decide how our findings will be reflected in an update of that draft. And yeah, then update the draft, and hopefully we can move some of the discussion from the team to the DMM mailing list to get more opinions on that and reflect that in the working group draft. So if you have comments now, I'm not sure how much time we have left, but I think
4 minutes.
That's good.
Can you go back to the deployment scenarios?
May please.
Chun Sanxiong from Huawei. You have a left picture. You have a left side. There's a network controller. Maybe this use case for more the smaller cell, and the right side will be for the micro cell. But in the 3G network, we maybe have some combination that a small cell combined with a micro cell. Then my thinking that whether the two scenarios can be used at the same two cases, controlled by the same mobile controller function, not just the left and right, maybe left and right.
So what you're saying is that both models will be deployed at the same time?
Yeah.
So, but is your recommendation
this
then?
This is the small cell, this is the micro cell, but okay, the whole network will be combined small cell and
but you recommend for this deployment of both models at the same time to have different protocol operation, or?
I mean that they be combined, implement or deployment, not just left or right.
Okay.
Maybe, yeah.
Got your comment. Thank you.
John, a slightly different comment on the mobility or the mobility control function. I just want to understand whether this also includes session management. By that I mean, the context that is related to authentication policy and so on of that connection, versus just the mobility. And
so the mobility control function, of course, has a session. We have the objective to not reflect all details of that session down in the data plane. Which function for this mobility control function you collocate from other functions which we currently have in a mobile communication architecture, that's deployment and solution specific. So, but I think the question is if the mobility control function has more features of what we currently have in different functions, that needs to be reflected on that interface.
Right.
Yes. I would hesitate to overload that interface for now. The interface itself should remain extensible so that additional semantics could be added. But I think for now we need a clear scope of how we go with this first specification.
Thanks.
Like you have additional slides? or you have finished all your?
No, we are in the next step slide, and that's the last one of this presentation.
Okay. So is there any other comments for Michael's presentation?
Satoru Matsushima from SoftBank. I think we had a good discussion around the, you show the table. That's kind of the debate of the which is better of the declarative or imperative. And also we have a discussion about the deployment model, which is centralized or distributed. I think all of them should be covered in the FTCP document. So the previous person mentioned that the combination of the deployment model is really realistic. But if we deploy that kind of the scenario, combined with both of the scenario, we need to take care about the scalability. It's really important, but the principle would affect that future deployment scalability, because if we have only imperative model, it's really difficult to scale, but it makes easy to migrate from current model to the future CPDP separation model. So when we have a declarative model, it's really good to have a scalability, because there's not so much tight interaction between the CP and DP. It's really, it makes relax the coupling between the CP-DP, because there's no hard, tight messaging between them. So declarative approach would be nice for the future real deployment, I think.
I think both models are valid, and I appreciate the comments here. We received others offline, and hopefully if there are more comments about this, if you have a position, just place it on the mailing list. So far we are further analyzing how much covering both models could be reflected in the draft and its update. And if you can support us by comments on the mailing list, that would be highly appreciated. But yes, I fully agree with your comments.
Yeah, we already have some basement model that's embody the declarative model, so we can base that existing model, and then we can establish the terminology of the DMM model in that fundamental declarative modeling. To catch what I mean?
Not the last point. Can you repeat?
So when we have a basement model, it's really generic declarative model. It will be very helpful to make our DMM specific modeling.
So you think that declarative approach should be the base approach?
Yeah,
and
yeah. We have some sort of the declarative model already. So that's a group-based policy, for example. When we have such basement model, it will be easy to make a specific term or specific feature on top of that.
Okay, so derive the imperative model from the declarative one. That's what. Yeah,
it's possible, I think.
Okay. Yeah, as I said, I think on the interface attributes wise, there may be commonalities. I think if we have more control in the control plane function, more attributes in addition need to be specified to cover that model, I think. And also command-wise, we of course need to go for different commands. So how far to reflect that in the draft, that's to be discussed.
Adding specific attribute and parameter, it's really easy business, and adding command as well. But important thing is, what's the basement of our model? We don't.
So I guess we don't have enough time for this topic. So Sri, you want a very quick comment?
Maybe just one, I think Satoru-san's comment, right? I agree with what Satoru-san said. I think if we can probably one model can be derived from the other model. I completely agree. I think if we focus more on the standardization of the attributes, right? Any new operations, like, I think the difference is the granularity of the operations, right? We can come out with new set of operations, but once we standardize the attributes.
Okay, so I have a final very short comments. I think the security consideration part, you still need some work on there, right?
Oh, yes.
Okay, yeah, okay. So let's thanks, Macro. So let's move on to the next agenda. That is deployment considerations. Zhihong.
Good morning, I'm Vic from China Mobile, and today I'm going to introduce the update of the DMM deployment scenario. And in this update, we, based on the feedback, adding more details, especially to the NFV deployment scenarios. And currently, the deployment scenario in our draft is NFV scenarios, SIPTOs, and W lines. And this time, I'm going to introduce the NFV scenario and the updates. And the current NFV scenarios is, as the figure shows, as the control planes is and the data planes is separated, and the control planes is in the mobile cloud, and they in the mobile cloud NFV-based cloud data centers, and they and the data planes can be implemented whether the NFA-based data centers or the legacy devices. And this slide shows the this time the update. And this is the DMM in the NFV system architectures. This can be shown as 4 layers. And the first is the it's the NFV orchestrators, and the others is the VNF managers, and the others is the Vim, and the below is the real NFV functions. And as we implement the DMM in the NFV system architectures, and the control planes and the data planes can be described as the can be modeling in the orchestrators, which is the NFV catalogs, and the it's like the yellow and the green circles as can be described as the description documents in the database. And also there is other 3 instances, which is the network service descriptions and the forwarding graph descriptions and the virtual link descriptions, which can describe the interconnections of the NFV model. And the working flow is going from the model file to the NBI interface and goes into the databases and is stored in the catalogs. And when we create the NFV functions, the core engine will use the description functions to transfer to the real NFV to the NFV documents, which can be implemented to through the Vim to the NFV functions to create the NFVs. So this is the update from this current draft. And the next step, we hope, firstly, we hope to collect the comments from the DMM deployment scenario design teams, and others, also the other comments from the working groups. And also the next step, we're now working on the coding of the previous architectures, and we hope to collaborate with more of the in the working groups. So that's all.
Okay, thank you, Vic. So Surya, I think the first question goes to you.
Yeah, I think we'll probably host some calls and we can review this and get some feedback.
Okay, yeah, we hope to give
Okay.
more contribute to the working groups, to the design teams. Yeah.
Okay, any other comments for Vic's presentation? Okay, if there is none, let's move on to the next agenda.
Okay, thank you very much.
Okay, so I think we have finished all the DMM related topic. So next, let's move on to the mobile IP maintenance part. So the next one is the PMIP extensions. So I guess that's your presentation.
Yeah, so this is a new work item that there's a new draft that we published recently. This is essentially about a minor extension to the PMIP protocol. So we have some large-scale deployments in community Wi-Fi where the MAC function is in residential gateways, right? These are. Can you go back to one of the, at least the picture maybe? Yeah. Next slide. Yeah. So if you look at this, a typical community Wi-Fi deployment, what you see on the left side is these are residential gateways, right? And these residential gateways, are today these residential gateways are, when an operator deploys this residential gateway, that's, any data that goes to that gateway is exclusively for that subscriber's access, right? Now a new model is coming out where, like, many of the operators have deployed this service called community Wi-Fi, where essentially they open up the CPE, right, for public access. In other words, there will be two SSIDs. What you see is essentially those color-coded. That's a representation of the SSIDs. One SSID is for the user, home user. Another SSID is for the public user. So in other words, if I'm working on a street, I could pretty much connect my mobile phone to any of the terminals that are in that any of the CPEs on that street, and I can pretty much, if I'm assuming that I'm a subscriber for that for that operator, I should be able to walk on the street. I should be able to use any of these devices and get connectivity. In other words, you see like a blanket of Wi-Fi coverage, based on these residential gateways. Now, in all of these deployments, some of these we have been literally in the tune of like millions, where all of these millions of access points connecting to these, it's based on PMIP architecture. In some other deployments, people also use Ethernet over GRE, but in Cisco, in our case, what we are saying is they put a MAC on the residential gateway and essentially a BNG on the BNG. There's a LMA function, right? Now a user comes in, we manage all the mobility happens based on this. Now one of the deployment challenges essentially, how to provision these various timer parameters on these MACs, right? How often do you do, binding update? What are the parameters for keep alives? Those are, if you don't, configure them properly, anybody, can provision whatever parameters, and essentially, there's, there is too much of signaling load on the LMA. So the proposal here is essentially when a MAC comes up, the LMA pushes this parameter saying that, you are supposed to register, these are the update parameters. Like, in other words, your lifetime, you should request is so and so. You do, refresh every, 2 hours, and you do keep alives not less than 5 minutes, right? So these are certain parameters which are essential for the MAC's operation. It will be pushed by the LMA. So a MAC comes up, it registers. As part of that, the LMA says, okay, these are the parameters that you need to use. So that way, the operator, because these MACs are distributed, and but if the assumption is that the operator will go provision each of these MACs with different parameters, it's very difficult to manage them. So here the proposal is essentially the LMA to push these parameters as part of the initial setup. So it's a one minor extension. You can go to the protocol format, right? So what we are defining is this new option. LMA comes up, and essentially this new option is what we call it as LMA control MAC parameter option. And it has sort of, couple of sub options. Next slide, please. One is for binding re-registration. If you look at this, are all the parameters in the PMIP protocol. So nothing new, right? Nothing controversial. It's already, if you look at 5213, 5844, these parameters are already defined. So, but the only difference here is instead of statically, configuring them on the Mac, the LMA pushes them as part of the initial setup. Next slide. Another is the heartbeat control, right? So, next slide. So these are, the couple of sub options, and in the RF, the draft explains. It's a very small draft. It explains the exact call flow. How the parameters are pushed. How the LMA pushes them to the MAG and the operational considerations. So key thing, right? This is essentially it's solving a deployment issue, right? It is not some new extension or anything. It's practical. We are using this technology, and we are hitting this issue, and many of our customers are asking for this extension. So what we want is essentially, an adoption for this document, right? This is a minor item, but it solves a deployment issue.
Okay. So, John, you have a comment?
Yeah, just a quick comment. I've read this draft and I think it looks good. Just one note. I mean, in the beginning, it says that it's to the IPsec ME working group.
Sorry, IPsec ME?
Right. It's a minor change that you.
Okay.
So that's a minor.
Okay, sure, I will take it.
But the content of the draft looks good to me, I think. Yeah.
Thanks.
Okay, so any other comments for this draft? Okay. Okay, so Sri, you want to the working group call for adoption?
Because these are deployment kind of drafts. I expect some discretion with respect to moving them fast on fast track.
Okay.
So
let's try to do that. So as usual, the first question is how many people read this draft? So please raise your hand. Okay. It's many, 6 people there. So so next question is how many people think the working group can accept this draft as the base of this work item? Please raise your hand. Okay, I guess the same number. Okay, so I think there is indeed some interest in people want to work on this.
Okay.
But I think we need to confirm on the mailing list for the adoption.
Okay.
Okay. So thank you. Okay. So next agenda item is another 2 call for adoption of the mobile IP maintenance work. So the first one is the prefix renumbering. So I think, is there any author of the document here in this room? Yeah, do you want to have any update summary of the draft? Yeah, I mean, you can give a very short summary about changes from the previous version. I don't have your slides, but I think you can just talk to have a very brief.
This is Zhi Yan, and based on the comments and feedback from the online and offline, we did some modification. We did some modification for the number 3 version of this draft, and basically we added the how to manage the session connectivity during the HMP renumbering. And another point is that we polished the presentation and the format of the reference. So we here want to call for adoption of this draft. Thank you.
Okay. So the same question is how many people have read this document, the prefix renumbering one? I think that's a very straightforward. Okay. 1, 2, 3. Okay, 4 people. So how many think is a good document for the working group consider as a base solution? Okay. Okay, even more people. Okay. So I think that's a good number considering, there's not much people currently working on this area. So let's confirm the call for adoption on the mailing list. So and the next document I want call for adoption is the multi-homing. So there's no presentation. Zuri, do you want to give us a summary to let people remember what's that draft? I think we have a lot of discussions in the previous meeting.
Right. So thanks, Depeng. On that, so we presented this document, like, Perik and myself, like, at least in the twice in the last, 3 or 4 meetings, right? So earlier, we were, the document talked about certain use case, which was about, use of this. First, before that, what is the extension about? The extension is essentially about a MAG's ability to register, 2 care of addresses, multiple care of addresses with LMA. Currently, between the MAG and LMA, the MAG can register a single care of address. Here, with this extension, the MAG can register 2 care of addresses. So that is actual protocol semantic. Now, in the initial versions of the document, Perik and we are focusing more on, trying to justify where all it can be used, and in the process, we talked about, use of this in, BBF use case and all of that, and that opened up some controversy because there's a section of people who are trying to publish a lot of work on the hybrid access, and essentially then they thought this is going to block that or something like that. Then I talked to you about the chairs and also to the area director Ben, and essentially the advice was not to touch that use case because that may create a new working group or whatever. So based on that feedback, we removed all the content with respect to any references to BBF use case. All we are saying is just a protocol semantic. In PV protocol, in MAG's ability to register multiple care of addresses is what the extension that we are asking for at this point. So the current version reflects that change. So no references to BBF, none of that stuff. It's a simple protocol semantic, like so many extensions we standardize on PV. We want the working group to support this minor semantic.
Okay. Comments?
So one comment, so I checked the draft. The use case, even though you are saying you are not referring, you're still referring to the DSL and the
multiple egress links. We say actually we don't talk about any of the BBF.
Whatever you have.
Maybe I'll take. Did you look at the 02 version? Maybe
actually has the DSL, right?
I'll take a look at that. But if it is, I will absolutely remove that reference.
So anyway, we are going to have the BOF, right? So if we are going to have that problem statement, then can we not wait for that?
So, but we are not talking about. We have removed the use case completely. Assume if there's some text somewhere which is left out or whatever by mistake, let's assume we'll take care of that, right?
But
with that,
also the hybrid access case?
We are not supporting. We are not talking about the use case. Hybrid access.
That for a single PDN connection, you would have like 2 IP addresses. What is the use case actually? If you're going to solve this, where you're going to use this?
In the PMIP context, within the PMIP context, between the LMA and MAC, right? In service provider Wi-Fi, or it could be any of the PMIP deployments.
So if you look at the PDN connection, are you going to say that you're going to have 2 IP addresses for the same PDN connection or 2 different PDN connections?
Actually, there's no PDN connection at all. This is like essentially the MAG obtains an IP address from the access network, right? So that is. It is an interface. Interface, right? It could have multiple egress interfaces, right?
For the same egress interface, you will have 2 different.
No, it's not for the same egress interface. Different egress. Typically, right? You can have one access. You could have satellite link. You could have satellite link. You could have.
And so what I'm saying is that once you go to satellite and LTE, you are still talking about the hybrid access case.
But hybrid access is, essentially they are talking about the broadband forum, what BBF is trying to address.
Well, so I think that particular thing we are really going to have, we will have the debate about that, right?
So, okay, maybe here is the point, right? As maybe I don't want to debate here, but if you look at multi-MP TCP group, they're doing the same thing. So maybe the problem is because we gave a reference to the hybrid access, some of the people who are interested in the topic are getting excited, but if you look at MP TCP is doing the same thing.
So I think I don't have anything against the approach what you're taking or anything. What I'm saying is that it will be much better if we can refer even the work what we are going to do in the hybrid access. That's the only thing I'm saying.
Actually, we don't want to go that route because that is a separate on a separate track. They may come out with a new protocol, new solutions. We don't want to object to that. We don't want to create this as a dependency to that or vice versa. It's a completely different tracks, right? You have a protocol, you have semantic missing, you want to address that, add that semantic. That's it. Yeah, that's why we'll remove complete use case.
My suggestion will be this, right? If you can respin the draft. So I think the draft what I at least referring to, it has got the DSL link and the LT. So can you just put what the exact scenario you're going to solve, and then we can.
So,
what you really want actually, that the MAG and the link. What
have you read the draft?
Yeah, actually I read it.
So what is the change you're asking?
No, so I'm just saying that I think what I'm seeing the version, it has got the reference.
Okay, so mobile IP protocols have support for multiple care of addresses. This is another, it's the same thing for PMIC protocol. That's it. So why is it anything different?
So my question is very simple, okay?
No, answer that question, right?
Are you going to have it for a single PDN connection, or you're going to have it for multi-PDN connection?
But what does
you're going to say that I'm going to have two different interfaces, correct?
Yeah.
And are they the same interfaces, or they are the different? Because what you're saying is that, oh, there is a Wi-Fi interface and there is an LTE interface, or there's a satellite link or an LTE link.
Right.
And to me, when you start going on that path, it actually goes to the hybrid access case.
But mobile IP is already on that path. If you look at mobile IP V4, if you look at mobile IP V6, if you look at NEMO V6, there's already supporting that semantic. Why is it different for PMIC case? So if you look at mobile IP V4 standard, we already have an RFC on that. Mobile IP V6, we have an RFC on that. NEMO, we have an RFC on that. Why is it, what is missing here? Why is that?
So I think I'm not saying that anything, what you're saying, if you have a clarity on what the scenario is, I think it's.
Scenario is essentially the ability for a MAG and to use multiple care of addresses. That's it. Exactly like what mobile IP V6 did.
I'm still trying to understand that what you're trying to achieve by actually doing this, because it seems to me that what he's trying to do is.
Can you, Danny, you can use MAG to let.
I think that what Sri is saying is, what he's trying to do is to be able to reflect the same functionality that mobile IP provides with proxy mobile IP. That's all. He found something missing in proxy mobile IP, and he's trying to fix that. That's all.
Is actually there, which is
no use case. Just proxy mobile IP should be able to provide whatever mobile IP provides.
So here's the thing, right? There is a gap which is fine, okay? But if there is no use case to back it up, then
every single protocol extension you don't drive based on a use case, right? Many of them, or it's a protocol semantic. I want to use a a secondary address on interface, for example, right? For that, I don't need to come out with a business use case and say that for solving that business case, I need to extend this protocol. There are protocol semantics and deployments. You need this.
There are many problems which you can look at that way, right? If you want to. But what we are going to solve here is really if there is any applicability.
I think my last comment on that is right. I think these comments are coming from one and only one thing. There's some people who want to do something on the hybrid access work. It is perfectly fine. We are not blocking that. That is the point here. I don't. The problem is, I don't want this work to be used to justify that work. I'm neutral to that work, but I also don't want to say that let's bring up there and let's create a working group. That's what is happening. That I'm completely against that. If you want to create a working group, absolutely fine. But don't say that bring it there. Let's do that. That is incorrect.
Okay, so let's give a very short summary about this. So in previous meeting, I think Sri has gave a moment. Yeah, Sri has made a presentation to explain the use case and the motivation of this extension. I guess it's a simple extension that to let the mic to have multiple care of address, because if you have multiple link, you will have more redundancy. So I think that's basics the use case. So Besset, you have comment on?
Yeah, my comment is that first of all, we discussed this I think several times before in the previous meetings, and I don't think there was interest from the group. The other thing is this draft is not the mobility draft. So I think it's out of scope with the
Actually,
it's a fixed.
Actually, I don't quite understand why
Fixed
it's
network.
not relevant to mobility because it's an extension of PMIP.
Yes, but it's not, it's for a fixed problem, not for a mobility issue. So use of PIN, so very artificial use of this PIN signaling to do something fixed to solve a fixed network problem, which is called hybrid access. So so it strips away all the mobility procedures of PIN and just uses this PIN signaling. So to me, this is out of scope with the
I think the draft itself is to extend the mobility protocol. So that's what I noticed. Yeah, Brian, you want to say something?
Yes, Brian Haberman, responsible AD. DMM has responsibility for the protocol maintenance of PMIP. That doesn't mean that those protocol maintenance changes have to be strictly related to mobility simply because it's in DMM. If it's a protocol update or protocol extension, it belongs here now. I will also point out that these are voluntary standards, which means if somebody else wants to use them for a problem that they have, they can. That doesn't mean that we have to have them come to us and say, do this, because we may want to use it for something else.
Okay, thanks, Brian. That's make very clear. So sorry, but we are running out of time for this topic. So shall we just go for the call for adoption for this document? So the first question is how many people have read this document? Please raise your hand. Eight hands, I see. Okay. So how many people think is a good base for the working group to solve this problem? Please raise your hand. Okay, the same number. So I think it's a sufficient number considering there are not many people currently working on the PMIP extension. So let's confirm the call for adoption on the mailing list as the next action. Okay, so I think we have finished all the items on the agenda, and we have two overflow presentations. The first one is for the deprecated prefix. So I think Lee, yes, okay. I can do that for you.
I'm Jung-Young. It's a very simple extension to NDP protocol. Actually, the current NDP protocol does not specify how access route obtain the duplicate network prefix information from mobile load. So, but in terms of IP mobility, mobile load may use each duplicate address. For example, previously configured address at the previous network for communication at the new access network. Mobile node may use the duplicate address only for keeping previously established communication at the previous network and possibly at the new network. And the mobile node use the preferred, default address for new communication at the new network. So the motivation, without knowing duplicate network prefix, English filter may filter all data packets with the duplicate address of the mobile load, and access router cannot establish by dynamical tunnel with the previous access router for data packet forwarding for the mobile load. So, but if the duplicate network prefix is known to the access router, we can solve the egress ingress filtering problem, and also we can easily make the bidirectional tunnel. So here is the proposal. The extension to RS and RA message. And for RS message, we are going to include duplicate network prefix options. And for RA message, we are going to have one simple flag to quickly receive RS message, including that prefix information. So here is the example. So that's it. Yeah.
Okay. Is there any comments for this draft? Okay, so yeah, Alex.
Alex Petrescu. The comment is obviously this has a important security risks, right? So how is it going?
Because our extension is for NDP protocol, so we can reuse send protocol to protect that option. And also because this option include a previous network prefix, okay, duplicated network prefix. So which means that we have to have some kind of proof of the previous network prefix ownership.
Yes.
Okay, we are going to work on that, okay?
You are going to describe it. Okay. Thank you.
Okay. Yeah, Brian.
Brian Haberman. I was reading the motivation in the draft, and I'm not quite sure you mean deprecated.
In terms of IP mobility, after handover, mobile load moved to the new network and configure his address at the new network. This address as a default address, it can, we say, preferred IP address. But if the mobile load want to keep the previous IP address, but going to use
the previous CARIB address.
Yeah, exactly. But I cannot say that is CARIB address. But in terms of mobile IP, that is CARIB address. Okay.
Right. Okay. So I think the document was a little unclear that you were talking about the CARIB address and not the home address. Yeah. Okay. Thanks.
Okay.
And if you really want to do this as RA or RS options, you're going to want to talk to 6-man.
Okay. Thank you.
Okay. So thank you. So let's. I think before we go to the last presentation, let's go back to our agenda. I think for the PME maintain work, we have another document that is Charlie's IDs. So, but I didn't receive any slides until this morning. So Charlie, you want a very short presentation for this? Okay.
Yeah, so this will be a pretty short presentation. There was some discussion about this draft, and thanks for a really extensive review by Sri. This is just a list of the changes. First of all, EPC is used in the document, and it needs to be explained that that's not LTE mobile core, packet core, and also make it clear why the inclusion of additional identifiers is important for mobile IP. So a little bit of language about that. There was a relatively, Sri made the comment that there needs to be more description about the specific MNIDs that are listed in the draft, and there's quite many of them. As one step along that way, I made a new table with some text description about each one, and so I think that it's pretty compact, more or less, and a good reference point within the draft. And then it was also requested to say a bit more about the security considerations for some of the identifiers. It's important that they remain confidential. So that can be obtained, that could be achieved by using, for instance, encryption as part of that. And so that was brought out within the security considerations. So that's, with the exception of one comment from Shri, there's also another piece of email from Hakima Chauchi that I didn't get around to, I didn't address that comment yet. But anyway, the major point I wanted to ask about, and this is the last part of my presentation, was it was requested to make a subsection for each mobile node identifier type to explain something more about what it was and the format and all that. And that can be done, but it would probably make the draft about 3 times larger, especially if I had to put in a lot of information about the format of each identifier. So before going to the, to the lengths of doing that, I thought it would be really worthwhile to ask the working group to, suggest what would be a happy medium on that. And I'm a little bit reluctant to duplicate the format of each mobile node ID, because then it, well, it sort of looks like a specification, but it's really not within the jurisdiction of this draft to make any such specification for those other identifier formats.
Okay, thanks, Charlie. I think the document is still in working group last call, but we lack some reviewers. So I'd like to suggest the working group, the member of working group, please help Charlie to review this document and send your comments to the mailing list to help us finish the working group last call.
Okay.
Thank you. So we still have 9 minutes. So let's go to the last overflow presentations. Is about VCP.
So Charlie's not here, so congratulations to her. Okay, anyway, so I think this slide has been presented last time, and so this is newly updated. The use case is about the community Wi-Fi, and so they are targeting about to virtualize the CPE to the data center in the network side. So the motivation would be, quicker deployment, fast deployment, and also would have low cost and easy for IPv6 migration for the home networking. So there are many, benefit for us to consider to drive this direction. So next page, please. So in this page, you can see there are multiple SSID announced at home, and you can share use, or you can use only at home. But all of the intelligence will be sitting in the center of the data center. We call it telecom integration, telecom integrated cloud to provide service for the home. And so next page, please. So this shows how the deployment is option 1 about how we really can deploy the CPE. You can see there's a one-to-one map from the physical CPE to virtual CPE here, choosing. And so they need something like then they need something access and aggregation for the multiple physical CPE, and then they bump to the network side. Next, please. The second one will be the virtual CPE as a solution function training. Then you can have the PNG as a classifier, and you do not necessarily to virtualize the CPE, because if you have 10,000 of physical CPE, then you have to using the tens of thousands virtual CPE on the outside. So that will be really performance challenging. But if you're using like a kind of classifier, then you probably need to, you can skip the too many virtual CPE over there. So that means that it's quite similar to the 3GP GI interface. So like a source function chaining, then we can do the virtual BRAS to do these kind of things. And so for the configuration of the physical CPU, you can using the access network SDN controller for the traffic steering, the traffic to the BNG side. So these are second options. Next page. They are okay. So the other one is the third option is not necessarily related to the virtual CPU side, but more like how we can decoupling the control plane and data plane for the BNG side. So this is you can integrate, for example, SDN controller with the BRAS control plane, and that will be more because both of the software implementation you can put on any server locations. So that is the we are looking at for the deployment. The next. So when we look at this deployment scenario, then we can see the different components have different capabilities. For example, if you look at the client side, you can see they need a specific VLAN ID to map to the which is SSID, and then you also have the QS metadata for the different VLAN ID. But similarly, you can see the agent side, they also need this mapping to classify. I mean, this could be used for the source function chaining classifier by mapping those information from the end to end until the net. So that's the idea. The next. And then the controller will later, we have to configure all of the physical CPU about the traffic goes to about the data plane side. Next page. So the conclusion need for this working group is we had lots of discussion about this use case about community Wi-Fi, especially using the DMM protocols. And so we are wondering, so if there's no current IETF document about virtual CPE, then this work is important. And also this work is quite important for service provider moving toward this telecom cloud solution of the future internet architectures. So we are expecting this one could be one with a standard track, and there'll be a protocol extension to the DMM protocols. And also we want to publish one of our architectures on this topic. This proposal has been, so we are asking for adoption under the WT4 for this document.
Okay, thank you, Hui. So we still have 3 minutes. So if anyone wants to discuss this, we can use that time.
I think this is valid. I think we should, under WT4, maybe, we should, as part of that, this document, if there's support, we should move this forward. Yeah.
Thank you.
Okay. Is there any other comments on this? Okay. Is there any other topics want to discuss this morning? Okay. So if none, I think we can conclude this morning's session. Thank you, everyone, for coming. Let's meet next time. Thank you.
So can I say correctly? So we have people supporting from the group and about this proposal.
You want raise hand off? Maybe we can do that offline. Okay, thank you.